Good morning, students. Today we are going to see predictive modeling from process optimization and control. What do you mean by predictive modeling? So, by the term predictive means means we are just forecasting the things. Okay, so the predictive modeling for process optimization and control is very important topic in chemical engineering perspective. So by using a model predictive control, we could able to achieve this predictive modeling. So the introduction goes like this. Predictive modeling involves using statistical or machine learning methods to forecast future outcomes. So the predictive to forecast the future outcomes, underline the word to forecast the future outcomes based on historical data. So predictive modeling involves using statistical or machine learning methods to forecast future outcomes based on historical data. In chemical and process engineering, it is crucial tool for optimizing operation, improving product quality and enable real-time process control. So any chemical process unit, whether a unit operation, any unit operation or a unit process, what we do, we use to optimize the operation. Let's say we have a distillation column or absorption column. So in a distillation column, we will try to optimize the amount of energy required in order to separate the two components because of the relative volatility. Okay. Similarly, in the absorption column, we will try to optimize the amount of air flow rate or the gas flow rate in order to absorb the solute from the gas phase to liquid. Okay, this is the absorption. So optimization is very important in any unit operation or unit process, improving the product quality and enabling the real-time process control. So predictive modeling involves using a statistical or machine learning methods to forecast the future outcomes based on the historical data. In chemical and process engineering, it is crucial tool for optimizing the operation, improving the product quality and enabling the real-time process control. What do you mean by real-time process control? In science, we will do simulation. Okay, real-time process control immediately once it has been data has been controlled, for example opening a wall or close the wall, okay, is a real-time process control. Okay, from the DCS system, I mean from the control room we could be able to operate the same thing, but in the same sometimes we will manually, I mean what you called in a model predictive control. Okay, mostly by machine learning models we could also can do the things actually in a automate, not in a real time way. Okay, so coming to the key objective of predictive modeling in process industries: forecast process behavior under various conditions, enhance decision making using data driven insights, improve operational efficiency and reduce cost, support real time control strategies like model predictive control. So model predictive control is a real time control strategies. Reduce the downtime by anticipating the failures and quality issues. The first point is forecast the process behavior under the various conditions. So how this will behave. For example, when the reflex ratio changes, what will happen to the optimization part? Okay, so as you know, in the distillation column, the futures are very important. I mean, the data which is like temperature and the reflex ratio are more predominant when compared to the other variables like number of stages. Okay, the temperature, pressure inside the column. Okay, so that we have seen in the last class. So forecast the process behavior under various conditions. So that we need to do in a predictive modeling in process industries. Enhance the decision making using data driven insights. So decision making, because of using the data driven insights. So by using the data driven insights, we need, it will enhance the decision making, improve the operational efficiency and the reduce cost. So why we need to do this predictive modeling? Okay, the predictive modeling is mainly used to reduce the cost as well as the improve the operational efficiency. So support real time control strategies. Predictive modeling support real time control strategies. Example, model predictive control. Okay, is a key objective of predictive modeling in process industries. Reduce downtime by anticipating failures or quality issues. So in the downtime, So in the last class we have seen the heat exchanger. So when the fouling occurs, so it will be predicted. Okay, that means 7 days in advance. Okay, before the real fouling occurs. Because of that, the energy consumption is less, the downtime period is very less, and things like that. So reduce the downtime by anticipating failure is one of the key objective of predictive modeling in process industries. So hope you understood these 5 important objectives of predictive modeling in process industries. And coming to the first, the data collection. So the data collection, how it can be carried out. For example, in a batch reactor. Okay, in a batch reactor, let's say what are the variables that has been involved in a batch reactor. If you see that one, the data in a batch reactor means mostly we will take temperature, pressure, the concentration of the reactant and the concentration of the product. So by using the sensors, we could able to collect this data. Okay, and coming to the DCS, distributed control system. In the class, we have seen elaborately what is distributed control system. A distributed control system is a computerized system used to automate and control industrial process. Okay, it is a computerized system used to automate and control the industrial process. It differs from traditional centralized control system by distributing control function across multiple controllers, enhancing reliability, scalability, and efficiency. DCS are used in various industries including chemical, manufacturing, and power generation as well. What are the key features of this DCS system? The distributed control functions are distributed across multiple controllers, improving system reliability and making it easier to manage large complex process. Real-time monitoring and control. DCS provide real-time data collection and processing, enabling operators to monitor and control process effectively. Enhanced safety. By automating critical control function, DCS can reduce the risk of accidents and improve the safety. Improved, it is also improved the efficiency, can optimize the process, reduce energy consumption, and increase the productivity. So these are the advantages of having a DCS. Okay, in the data collection. The scalability. The DCS can be easily scaled up or down to accommodate the changing process requirements. And also it is very integrated. DCS can be integrated with other systems such as supervisory control and data acquisition. That is a SCADA system. So DCS we can go, it also can be integrated with the SCADA. But then we will see actually what is the SCADA system. In the last class also I told you what is SCADA system. It's nothing but a supervisory control with and data acquisition. Supervisory control and data acquisition system. To provide, the DCS can be integrated with the SCADA to provide a comprehensive view of the entire operation. What is the application of DCS in chemical processing? Automating the reactions, distillation, and the other chemical process. In the manufacturing, controlling assembly lines, packaging, and another manufacturing operation. Apart from that, it also used in mining and oil and gas. So DCS in application in mining, automating mining operation such as extraction, transportation, and processing. So in the field of oil and gas, the DCS is used controlling oil and gas production, refining, and transportation. In water and wastewater treatment, the application of DCS is automating water and wastewater treatment process. Pharmaceutical processing, controlling pharmaceutical manufacturing, including drug synthesis and formulation. So DCS is a computerized system used to automate and control the industrial process. Underline the word control the industrial process. Okay, so hope you understood what is the source, how to collect the data from either by sensor or by means of the DCS system. Coming to the SCADA system, the SCADA system is a supervisory control data acquisition. Okay, so that's why this SCADA can be integrated with along with the DCS. Okay, I told you. So the SCADA is a hardware and software combination that enables industrial process automation by capturing real-time data from sensors and equipment. It allows for remote control and monitoring of industrial process, gathering data from field devices like sensors and actuators, and displaying it on a human machine interface for operators to make informed decision. Underline the word human machine interface for operators to make informed decision. What are the key features and functions of SCADA? The data acquisition, the SCADA system collect real-time data from various sensors and devices in the environment. Control, they enable remote control of equipment and process, allowing operators to adjust settings and make changes from the central location. Supervisory function, example, the SCADA system provide a high-level view of industrial process, allowing operators to monitor and analyze the data being collected. The data analysis and reporting, they can be used to analyze historical data, generate reports and track performance. The communication, it is also used. The SCADA system facilitate communication between different parts of the industrial plant. Underline the word different parts of the industrial plant, ensuring that all relevant information is shared in a timely manner. What are the components of this SCADA system? Which I already told in the last class, but again I just highlight this thing. Okay, in a predictive control, when you try to collect the data from the what is the source, either it will be obtained from the sensors, DCS, SCADA or LAMS. LAMS I will explain to you shortly. So in the components of the SCADA system, field devices, these are the sensors, actuators and other equipment and that collect from the industrial process. So RTUs are, what do you mean by RTUs? RTUs is a remote terminal units which are microcomputers that receive data from field services and transmit it to the central SCADA server. Communication network. A communication network such as local area network LAN or wide area network WAN is used to transmit the data between the RTUs remote terminal unit and the SCADA server. The SCADA server process data received from the RTUs. RTUs is a remote terminal unit and displayed it on the HMI, human machine interface. Okay, the human machine interface provides a graphical user interface for operators to interact with the SCADA system. Okay, so the industry is using SCADA systems, oil and gas, manufacturing, energy, wastewater treatment, and as well as transportation. So in oil and gas, monitoring and controlling the pipelines, refineries, and other oil and gas facilities. So in manufacturing, automating and controlling manufacturing process such as assembly lines and production plant. In the energy sector, managing power generation and distribution as well as the smart grid application. In wastewater treatment plant, monitoring and controlling the water quality and treatment process, this SCADA system has been used. So the sources for the data collection, the sensors, DCS, SCADA and LAMS. Okay, coming to the LAMS system, do you have any idea about what is LAMS for the data collection? So LAMS is nothing but laboratory information management system. Is a software-based solution that helps manage laboratory operation by streamlining the workflow, tracking samples, and managing data. Again, this is a this is mainly used in the data collection. And the types of data collection is time series, which we have seen very good examples I told you in the previous class regarding the time series data. Let's have a batch reactor and try to find the data collected from different with respect to time. Okay, like every 5 minutes just collect the data. Okay, either from the temp what you call examples such as temperature and pressure, and the categorical data. Categorical data means is a yes or no and things like that. Like decision tree, we will have the categorical data, right? So the continuous and the data may be continuous. So the components of predictive modeling, first part is the data collection. And coming to the data pre-processing, the cleaning, normalization or screening, future engineering and selection. So data processing, how to do the data pre-processing, cleaning. So the outliers, okay, the outliers are, and the outliers means the points which has been deviated from the normal values and the missing values. These are the data pre-processing. So this is also part of the predictive modeling. Okay, normalization and scaling, which I already discussed in the previous lecture. Future engineering and selection is all we have studied in the previous lecture. And coming to the model selection, so the model selection, the statistical models, the linear regression, and ARIMA. So what do you mean by ARIMA? So I believe that you understood so far what has been covered in today's class. Okay, so please try to refer back the things which are whatever you have studied earlier. If you have any doubt during the class when you come for the next class on face-to-face section, please try to ask. Okay, so coming to the here, the model selection, the ARIMA. ARIMA is the auto-regressive integrated moving average. It is a statistical model used for time series forecasting. So ARIMA is nothing but a auto-regressive integrated moving average is a statistical model used for time series forecasting. Underline the word time series forecasting. It helps predict future values of time series based on its past values and relationship with previous error terms. ARIMA is a powerful tool for capturing patterns in time series data and making accurate forecasts. So here is a more detailed explanation goes like this. The autoregressive, this component models the relationship between the current observation and its previous values. In other words, it considers how the past values of the time series can use to predict the present value. Okay, coming to the integrated part, this component deals with the non-stationary data. Non-stationary data as a trend or seasonality, meaning it means and variance change over time. The integration step involves differencing the data to make it stationary. Coming to the moving average, this component models the relationship between the current observation and the residual errors from past forecast errors. The error terms are the difference between the actual values and the predicted values. So the ARIMA P, D, Q, the model is often represented as ARIMA P, D, Q, where P represents the order of the autoregressive model. D represents the degree of differencing. Q represents the order of the moving average model. So time series forecasting, ARIMA models are used to analyze and forecast the future values of time series data such as stock prices, sales figures, or even the weather pattern. So this weather pattern I told you in the last class. Okay. So the stationarity, a key concept in ARIMA is stationarity. Their time series is considered stationary if statistical properties like mean and variance do not change over time. Differencing is used to achieve stationarity in non-stationary data. ARIMA models are widely used and effective approach to time series forecasting, for providing a valuable tool for business and researchers to make prediction, and also is mainly used in the chemical process industry. So the ARIMA is a approach to time series forecasting. So underline the word time series forecasting. So the model selection, the ARIMA, or maybe a linear regression. And coming to the machine learning models, we have decision tree, random forest, support vector machine. Okay, so these all what do you call it? The random forest is a supervised learning. There is a relationship between the dependent and independent variables. Support vector machine is again a supervised learning. Okay, so this machine learning model. So we need to select either a statistical model like ARIMA or linear regression, or machine learning models like decision tree, random forest, support vector machine, neural networks, and things like that. So the deep learning models, neural networks. So it's a deep learning model is a long short-term memory for time series. So this is mainly used actually speech recognition and tone pitch. Okay, which I already discussed elaborately. The LSTM, long short-term memory model. Okay, and coming to the fourth one, model training and validation. This is very important. Split the data set. So training. So when you want to train, usually they will do for 80% training and testing for 20%. And also we need to validate the model. So if it is a statistical model, we will validate by means of knowing the R square, okay, mean absolute error, root mean square error, and so on and so forth. Okay, so the cross validation for robustness. So we need to cross validate this. So and also the actual value and predicted value. If we try to draw a graph, obviously it will help you to identify whether it's overfitting or underfitting. So mostly the model is supposed to be a R square value is close to 1. That means Okay, the actual predicted value and actual value is same. Okay, so the forecasting the time series data, that is a statistical model ANIMA has been used. Okay, so what is process optimization? So I think yeah, since you are in already at the end of third year, you know what is process optimization. I don't want to touch upon this part very elaborately, but I would just would like to say process optimization improving the process parameters to achieve the maximum yield or purity, minimum energy or resource consumption, reduce the environmental impact. So obviously the cost estimation also. Okay, they didn't mention about this one is a cost, the process, because the process economics you study actually when you come to the I think final year or for R22 whether they are having it right now, I'm not sure. Okay, so when you see here the process economics, I think you're going to study in next semester, seventh semester, I think. Okay, so the process of economics is also an important parameters in the process optimization. Okay, so because when the people say the process of the energy is less means what we call the obviously the cost will be less. Okay, so maximum yield of purity. I would like to explain about my PhD work. So my PhD work, so we are talking about this spray dried powder. That is a maximum yield we are looking for. Okay, let's say what I did. I just take a fruit and peel off the fruit, peel the skin of the fruit, and then try to cut down into a small pieces. Okay, then I subject that fruit into a drying process like oven drying. Okay, so once I dried, what happens actually? Then I grind it into small pieces and make it into a smaller particles so that a larger the surface area we will obtain. So I just added a solvent methanol. Okay, and then try to extract the bioactive components which are present in the dried thing. So once it has been done, I have added some additives into the extracted solution. Then I subject the liquid into a spray drying techniques. When you see in the spray drying, the liquid has been converted into product. Okay, so the purpose of having this encapsulation technique is that so that the bioactive components has been encapsulated by additives like K-coregenin and maltodextrin. So this compounds will help you to allow to slowly release the drug. Okay, so the objective of to encapsulate the bioactive component is to cure the cancer because that fruit contains high antioxidant and flavonoid content as well as phenolic content. Okay, so if you have a total high antioxidant activity, obviously that will be cure to remove the helpful to diagnose the cancer. So here the product, the process is spray dryer. The spray dryer we need to give you a yield, that is a product, that is that product, that because of the stickiness of the stickiness nature, the product yield may be reduced. So by adjusting the glass transition temperature, we could be able to get a larger amount of yield. Okay, so this is how my process is. So maxing the yield higher. So what are the things I need to do? Whether I need to try to find the glass sensation temperature and try to vary the glass sensation temperature, or else I need to reduce the amount of additives which has been added in the extractive solution. Okay, so this is how this control works. So when you put a model predictive control, we can put a controller on the what you call the inlet of the inlet of the uh, feed, okay, which is coming to the spray dryer. Okay, so improving the process optimization to achieve the maximum yield, minimum energy or resource consumption, and reduce the environmental impact. So here the extraction, what I during my project, I not only did a hot water extraction work, okay, or else the soft salt extraction, I went for a supercritical fluid extraction. So you should have a domain knowledge actually to understand the process first, and then we should know how to do the modeling, how to do the predictive model with the help of model predictive control. Okay, hope you get an idea about all this. Okay, coming to the next point, how predictive modeling helps. So that is a very important question, right? So simulation of scenarios before implementation. So let's say in the same scenario, yeah, I did my experimentation and then try to do the thing. So simulation of scenarios before implementation. Um, Before I go for doing experimentation, I can do the simulation, okay, of scenarios before implementation. Optimizing the algorithm, example genetic algorithm, can use predictive models to find the optimal settings. Okay, integration with the digital twin models for real-time feedback. So what do you mean by digital twin models? Do you have any idea about what do you mean by digital twin models? So the digital twin is a virtual representation of a real world object, system or process that is continually updated with real time data. A digital twin is a virtual representation of a real world object, system or process that is continuously updated with the real time data. These virtual models act as a digital counterpart, allowing for simulation, integration, testing and monitoring of the physical asset. So the virtual representation, a digital twin is a digital model of physical object or system, not a static 3D model but a dynamic evolving entity. Real-time data is updated with real-time data from sensors on the physical object, allowing for continuous monitoring and simulation. Dynamic and evolving digital twins adapt and change based on the physical asset, behavior, and life cycle, reflecting its current state. What is the purpose of this digital twin? Okay, simulation and prediction. Digital twins allow for simulating various scenarios and predicting potential issues or performance characteristics. Optimization and improvement. They help identify inefficiencies and opportunities for improvement in the physical counterpart. It is also used in predictive maintenance, design and development, monitoring and control. So how it is helpful in the predictive maintenance? Digital twins enable predictive maintenance by analyzing data and identifying the potential fault before they occur. In design and development, they can also be used in the design phase to test and validate the prototypes, reducing the need for physical prototypes. For monitoring and control, digital twins provide a centralized view of an asset performance, allowing for remote monitoring and control. So, what are the key features of this particular digital twin models? So, digital twins rely on the sensors to collect real-time data about the physical asset. Data analytics is also one of the key features of digital twin. The data collected is analyzed using techniques like AI, artificial intelligence, and machine learning. Simulation and modeling is also another key feature. Digital twins use simulation and modeling to represent the behavior of the physical asset. Coming to the communication, they communicate with the physical asset, enhancing the exchanging the data and allowing for control and adjustments. In visualization, digital twins often include visualization tools to provide a clear and interactive representation of the physical asset. So, the examples of digital twins in the manufacturing, healthcare, and transportation sector, as well as energy sector. So, in manufacturing sector, digital twins can be used to monitor and optimize the performance of machinery, predict equipment failure, and improve production process. In healthcare, digital twins of medical devices can be used to monitor their performance, predict the maintenance needs, and improve patient care. In the energy sector, digital twins can be used to monitor the performance of wind turbines, solar panels, and other energy infrastructure. It is also used in smart cities. Okay, can be used to simulate the behavior of cities, optimize the traffic flow, manage energy consumption, and report improve the resource allocation. So these are the things of the about the key features of the digital twin. So integration with the digital twin models for a real-time feedback. Okay, so how predictive modeling helps? It is helpful in the simulation of scenarios, okay, optimization algorithm, as well as the integration with the digital twin models. Coming to the traditional predictive control, traditional control that what we are using actually in a process control lab, okay, is a reactive, okay, traditional control. We are using a DCS system, okay, distributed control system, can feedback based and less adaptive. Whereas in a predictive control, by using a model predictive control and using the algorithm, so it's a very proactive model based, actually is a not a feedback based, it's a model based. The model will try to adjust itself to find the according to the data and try to adjust the other parameters and highly adaptive. Okay, coming to the model predictive control, uses a dynamic model to predict the future plant output. So model predictive control uses a dynamic model to predict the future plant output, solves an optimization problem at every time step, incorporate constraints on input and output. Underline the word model predictive control incorporates constraint on input and output. So what is the benefit of model predictive control? Handles multivariable system well. For example, you are just collecting a data from a distillation column, different parameters like temperature, feed temperature, feed flow rate, the now reflux ratio, pressure and temperature inside the distillation column, the number of stages, the deboiler duty, condenser duty. Okay, so these are all data can be taken. So adaptive multivariable systems. So even for a batch reactor, okay, the temperature, pressure of the batch reactor, the concentration of the reactant. Okay, so multivariable it will handles multivariable system well, multivariable system well, and predict and avoid the constraint violations, adaptable to non-linear time varying process, uh, adapted to non-linear time varying process. So coming to the application, so as I told you, so I have already given an example for distillation as well as the bioreactor. So the reactor, batch reactor. So they have given here the bioreactor monitoring. So in a distillation column control, predict the product composition based on reflex and feed condition, optimize the energy consumption. So why they say reflex ratio and feed condition? So these are found to be a features very comparatively very important parameters when compared to the other things. So this one has been considered. Okay, predict the product composition based on the product composition. What they here they mean is the distillate purity. Okay, so optimize the energy consumption. So the revolve duty. Okay, so optimize the energy consumption, the amount of energy which need to be needed that can be optimized. Okay, so bioreactor monitoring. Predict the biomass or product concentration. What is bioreactor? Bioreactor actually where we will do the biological process. Okay, so let's say you are just using a or by using enzymes and trying to convert the reactant into product or fermentation. Examples is all can carried out in bioreactor, right? So predict the biomass and product concentration, control temperature, pH and feed rate, catalytic reactor optimization, model reaction kinetics using historical data, optimize the temperature and the residence time. Coming to the catalytic reactor, okay, catalytic reactor optimization, model reaction kinetics using historical data. So from the previous data, just try to find the reaction kinetics. Okay, and then optimize the temperature and the residence time. Okay, these are the applications actually for the thing. Okay, hope you understood the chemical engineering application. Okay, regarding the model predictive control, I mean, you can adapt a model predictive control all these process. Okay, as well as what you called prediction. So coming to the what are the tools which can be used? Okay, so in machine learning, so the machine learning where you can have a support vector machine or what you called deep learning like a neural network, or whether you can write it by using a Python or R programming. So we have a scikit-learn, XGBoost, and TensorFlow. We will try to explain. I will try to explain if you want to know about this particular tool. Okay, but I just give it to you. Just go and explore this type of tools which has been used okay in the programming language. Okay, I'm coming to the thing we can also do in MATLAB or Simulink. We can go for Aspen Plus or Aspen DMC. Okay, the PA system and data analytics tool. Okay, coming to the PA system, so I just would like to explain what is PA system. Hope you understood so far what has been covered. If you have any doubt, please feel free to note down right now and just ask me when you come and meet me during the face-to-face section. Okay, so the Aviva PEA system is a data historian and asset management platform that collects, stores, and manages real-time and historical data from various sources like sensors and control system. So the Aviva PA system is a data historian and asset management platform that collects, stores, and manages real-time and historical data from various sources like sensors and control system. It allows users to visualize, analyze, and report on data, enabling improved decision making and operational efficiency. So the core function, the data collection and arching. The PI system collects data from various sources including sensors, controllers and other systems and store it in a time series database. Underline the word and store it in a time series database. Data access and visualization. It provides tools for users to access, visualize and analyze the data through dashboards, reports and other applications. Data integration and analysis. The PA system can integrate data from different sources, enabling a holistic view of operation. Asset management. It helps manage assets by tracking their performance, identifying potential problems, and enabling predictive maintenance. So what are the key components of PA system? The PA server, PA data archive, PA asset framework, PA connectors and interface. So when you say PA server, the central component that manages data collection, storage and retrieval. PA data archive efficiently stores and archives time series data. PA asset framework provides a centralized repository for asset models and hierarchies and equipment, whereas the PA connectors and interface connect the PA system to various data sources. So what are the benefits of this adapting a PA system? Improved efficiency, enhanced asset management, data-driven decision, compliance and security. So I will just go one by one. How it has been improved efficiency? By providing real-time data and insights, the PA system helps improve process efficiency, reduce downtime, underline the word reduce downtime, and optimize the resource management. Coming to the enhanced asset management, it supports asset health monitoring, predictive maintenance, and overall asset lifecycle management. Data-driven decision making. The PA system enables data-driven decision making by providing a comprehensive view of operation and historical data. Coming to the compliance and security, it helps. That means the PA system can help organization meet regulatory requirement and enhance the security by tracking and analyzing the data. So the examples or use cases is predictive maintenance, process optimization, quality control, and energy efficiency. So the PA system is used in predictive maintenance, analyzing the data trend to predict the potential equipment failure and schedule the maintenance proactively. Process optimization, identify the bottlenecks and inefficiencies in process and optimization then based on the real-time data. So bottleneck, debottlenecking. So is a family commonly used debottlenecking. I will cover after this. Okay, what is debottlenecking? Okay, coming to the quality control, it PA system monitoring and analyzing the data to ensure product quality and identifying the areas for improvement. Coming to the energy efficiency, the PA system tracking energy consumption and identifying the opportunities to reduce the energy waste. So the tools and performance. Okay, when you see here the programming language or MATLAB or Simulink, Aspen Plus, these are all tools, software tools, which has been used for the model um, uh, for the modeling. Okay, for the modeling. So I just told I will get back with the debottlenecking. So debottlenecking is nothing but try to maximize the amount of the maximize the amount that can be operated under certain conditions. For example, if you have a reactor, okay, so most of the time we will not fully operate at a higher thing. So almost 80% of the volume of the reactor will be filled and then we will do it. So the debottlenecking will help you to achieve a maximum amount of volume of reactor that can be that can be allowed to operate. Okay, so this is a very important thing. So you just think of the tools and platforms which has been used to the predictive modeling. Okay, so coming to the challenges and consideration, data quality and availability. So the sensors, if we do is not drifted, I mean obviously what will happen? The correct data will not be obtained. Obviously that leads to a predictability in a wrong way. Okay, so model interpretability and complexity, that is also very important. So what is the type of algorithm you are using actually for the model interpretability? Okay, need for domain knowledge integration. So obviously without domain knowledge we could not able to think. So the accuracy and explainability is also a very important factor. where some of the times the domain knowledge overrule the accuracy, and that will help you to for many of the cases in the explanation with the authorities like regulatory agencies like USCPA and the allowing authority which will allow to run the process. Okay, so the model drift over time requires retraining. So these are the challenges and consideration for the doing the model predictive control. Okay, so or is the yeah, MPC model predictive control. Coming to the future direction, integration with the Internet of Things and edge computing. Coming to Internet of Things, I would like to share my experience when I was working in one of the private college. I used to, I just design a what you call biogas reactor. Okay, biogas plant. Okay, so what I did is that I just taken bought a very 10,000 liters capacity of a tank. Okay, it's like looking like a syntax tank where the cow dung has been added along with the water. Okay, and then the vegetable wastes have been added into that. So what will happen when this compound has been added and water has been supplied at the outer annular space? Okay, obviously after some time, because of the digestion of the material and as well as the what you call cow dung, the biogas will be produced. Okay, the methane will be produced. So the methane production can be notified by increasing the volume of the reactor, volume of the tank. So how the setup will be looking like is that okay, it will be push the gas which has been formed to push the tank towards up. So it's like a bulging what you call the stomach. Okay, so bulging stomach, how it looks after you eat or something, it will bulge, right? Similarly, the biogas has been produced, it will push the thing. You can also see the YouTube how this biogas plant can be set up. Okay, so when I try to produce this large amount of methane by using the digestion of the what you call it, the waste material which has been obtained from the kitchen. Okay, so that will increase the this methane can be utilized for the heating purpose. Okay, the methane gas can be used for the heating purpose. Okay, I've run this experiment, this project, and then produced the biogas and tested the calorific value of the gas. Okay, so this is how I did. During this point, I have an idea of connecting with the Internet of Things. So the IoT will help you to automate it and then try to collect the data, how much is the amount of gas which has been produced in the tank, okay, to your mobile. Okay, so and also the similarly water level. For example, the water level in a tank is getting reduced. Okay, so I want to make sure that if 40% or 50% has been achieved, I need to pump the water to the tank. Okay, so it automatically give a sensor. The sensor data can collect the data and it will give the data to the mobile or to the control room. So integration with the Internet of Things and edge computing is all automation. Okay, Internet of Things and self-learning models with reinforcement learning. So the reinforcement learning I already told you in the last class elaborately, so I don't want to touch upon right now. So the self-learning models with the reinforcement learning are the future directions, more robust hybrid models combining physics-based and data-driven methods. So the summary goes like this. Predictive modeling is a cornerstone of modern process engineering, enabling smarter, more efficient operation. Its synergy with optimization and control strategies leads to enhanced safety, profitability, and sustainability in process industries. Predictive modeling is a cornerstone of modern process engineering. So we try to find it out what is going to happen, so that what happened, we will try to avoid the shutdown period. Okay, for example, in heat exchanger because of fouling, which we have discussed. Okay, so it's a cornerstone of modern process engineering, enabling smarter, more efficient operations, so that the process will be efficient. Okay, so that means perfect efficient operations. A synergy with optimization and control strategies leads to okay enhanced safety. Model predictive control, when you apply model predictive control, it automatically varies the input to the system, so that we need not wait until there is a very vast variation. So that because of doing this model predictive control, one of the advantages is the product formation, the safety, the quality aspect will be very high. because it will not deviate from the thing. So it automatically adjusts. Model predictive control, okay, will try to identify the things and then adjust accordingly. Okay, the synergy with optimization and control strategies leads to enhanced safety, profitability, and sustainability in the process industries. So maintaining a consistent uniform rate is not possible for any unit operations or unit process, but because of implementing this type of control, model predictive control, okay, that will help you to capture the things in a very efficient way. So with this note, I just try to conclude today's section. So hope you understood what has been covered in today's section. Okay, so I just for a quick summary, I would like to touch upon what is a predictive modeling, okay, and how it is used for the process optimization and control. So predictive modeling involves the statistical and machine learning methods. Okay, the key objectives of predictive modeling has been highlighted over here. And what are the components of predictive modeling? One is data collection, data pre-processing, model selection, model training and validation, process optimization. Okay, so these are the four important points: data collection, data pre-processing, model selection, and model training and validation. These are the components. Coming to the process optimization using predictive models. So what is process optimization? How predictive modeling helps? Okay, so in that we have a comparison between the traditional and predictive control. Coming to the process control using predictive modeling, we have model predictive control, benefits of model predictive control, and the application in the chemical engineering have been we have gone through. Okay, hope you understood what are the platforms which can be used actually for this uh, model predictive, I mean the algorithms, okay, or the softwares which need to be used. Okay, either using a MATLAB or Aspen Plus, Aspen DMC, okay, and a PI system and data analytics tools. And coming to the Aspen DMC, what is Aspen DMC? Any idea about it? So we have studied actually what you called Aspen Plus and Aspen ICs. Okay, so what do you mean by Aspen DMC means? Okay, so I just would like to explain Aspen DMC. Aspen DMC refers to Aspen Dynamic Matrix Control Technology, a model predictive control method widely used in the process industry. This I forgot to explain during the class. That's why I just talk about this Aspen DMC and then we will wind up the section. Aspen DFC refers to the Aspen Dynamic Matrix Control Strategy Technology, a model predictive control method widely used in the process industry. Underline the word widely used in the process industry. It aims optimizing the plant operation by using the mathematical model to predict the future behavior of the process and then adjust the control action to achieve desired outcomes. Aspen DMC is a core part of Aspen Tech Aspen 1 Advanced Process Control Platform. So the Aspen 1 which we have seen, okay, Aspen Plus and Aspen ISIS, okay, which we have been using in what you call process integration, process modeling and simulation subject, integrated subject. Okay, so I don't want to touch that part. So just try to find it out. Dynamics DMC is a dynamics matrix control, a specific type of model predictive control algorithm that uses a linear model of the process to predict future behavior and optimize the control action. So in dynamic matrix control, it is a specific type of MPC algorithm, model predictive control algorithm. Note it down. Dynamic matrix control is a specific type of model predictive control algorithm. Model predictive control strategy that uses a mathematical model of the process to predict its future behavior and then adjust control action based on this prediction. So the Aspen Tech, a software company that develops advanced process control technologies, including Aspen DMC, Aspen DMC Plus, and Aspen DMC 3. Okay, so these are the things which are there in the thing. So just go and see what is Aspen DMC 3 and so on and so forth. I don't want to touch upon very deeply into that part. So these are the tools which has been used. Okay, so are the predictive control, model predictive control. Okay, so try to understand. Okay, predictive modeling. Okay, not model predictive control is one of the type. Okay, predictive controlling, model predictive. Okay, so with this I just stop it here. Predictive modeling is a cornerstone of a modern process engineering. Okay, so with this note I just stop it here. Hope you understood. Hope you understood something about the content which has been delivered today. We will, if you have any doubt, please note it down. We will see in next class.